Hello students, in today's lecture we will be discussing about skin depth in good conductors, in dielectrics or the poor conductors, what is the formula and how does skin depth vary in an electromagnetic wave. So first let us understand what is meant by the word skin depth. See, skin depth basically means the depth of penetration that has been undergone by the electromagnetic wave. That means how much successful has the EMT wave been in penetrating a media. That is, be it a conducting media, be it a dielectric or an insulator. Okay. Now, see, we know that an EMT wave, when it propagates, it takes up the mathematical expression as electric field intensity equal to E naught e to the power of j omega t minus gamma z. Here you can see this is basically exponentially that the wave is decaying or the damping is occurring. Omega is angular frequency, t time gamma the propagation constant, and z across the z direction. So in good conductors the damping is very high. Damping, what does it mean? Exponentially the decay of the wave is very high. So the amplitude decreases with increasing distance. When the distance increases, the amplitude of the wave, suppose the wave is going this way, so it will decrease very fast. Its amplitude is going to decrease very fast and the EMT wave will get totally attenuated, right? Now skin depth or the depth of penetration is an important factor because it helps us to describe or tell about the behavior of conductors in an EMT field or even about radio wave communication. Here, all these places, we need to know about skin depth or the depth of penetration. So mathematically it is the distance or the distance in which the strength of electric field associated with an electromagnetic wave reduces to a factor of 1 upon E times of its initial value. 1 upon E times of its initial value or the exponential decay of the wave. So the distance for which the electric field or the amplitude of electromagnetic wave decreases by a factor of 1 upon E to its initial value is basically satisfied by the equation alpha z equal to 1. So alpha z is equal to 1 or z is the penetration depth. So you can just say is this much. So the penetration depth is 1 upon alpha, which is equal to attenuation constant, right? So we know attenuation constant is a complex quantity, alpha plus I beta. So attenuation constant comes from this gamma word of complex quantity where the real part is attenuation constant and the imaginary part is attached with phase constant. So your skin depth is equal to 1 upon omega angular frequency into 1 upon mu permittivity divided by 2 into 1 upon under root 1 plus sigma square is the conductivity, omega square, epsilon square minus 1 to the power of half, that is square root. Now for good conductors, the ratio of conductivity divided by angular frequency into permittivity is very high. It is greater than 1. So in the expression for propagation constant, which is a complex quantity, we can neglect the term mu epsilon omega square can easily be neglected, and we are left with propagation constant equal to under root j omega mu sigma. Now for the EMT wave, we will solve it for the exponential component. E to the power of I theta is equal to cos theta plus I sin theta. So we are going to solve this expression in order to get an expression for skin depth. So under root j iota will be at an angle of 45 degree, that is pi by 4. We can also write 45 degree equal to pi by 4. Here 45, 90, 180, 3 pi by 2. So under root j is coming at 45 degrees. So gamma is under root omega mu is sigma e to the power of I pi by 4. Where what is this? E to the power of I theta is cos theta plus I sin theta. Theta I will write pi by 4 because at pi by 4 I get under root j, this value under root j. So pi by 4, this one, cos pi by 4 and sin pi by 4 is 1 upon root 2. We get the value. Now we will compare the real and the imaginary parts of the above wave. So alpha is the real part and j beta is the imaginary part. So the real part is under root omega mu sigma by 2. This is what we get for attenuation constant, and same thing for phase constant. Now we know that skin depth is equal to 1 upon attenuation constant. So for good conductors, the value of attenuation constant has come out as under root omega mu upon sigma. So the skin depth for good conductors, skin depth is, for good conductors, it is 1 upon alpha, which is equal to 1 upon under root omega mu sigma divided by 2, which is equal to skin depth del is equal to under root 2 upon omega mu sigma. Mu is omega is angular frequency, so it is 2 pi f. We can write skin depth as under root 2 upon 2 pi f mu sigma. So this 2 and this 2 gets cancelled, and you are left with skin depth for good conductors is 1 upon under root pi f mu sigma. This is the formula for skin depth of good conductors. Now notice that skin depth is inversely proportional to frequency. Skin depth is inversely proportional to frequency. That means as the frequency increases, the skin depth decreases. Like skin depth for copper is approximately, skin depth for copper, let us take it for 1 or 2 simple media and see what the value of skin depth comes out as. Skin depth for copper, approximate value, if we take and judge, then let us see for copper, the skin depth for copper is approximately say 6.6 into 10 to the power of -3 meter. For microwave frequencies, around microwave frequencies. Now basically what happens is that for all practical purposes where you need to find out skin depth for a good conductor, the wave vanishes after traveling a certain distance and it becomes insignificant after a distance of approximately greater than a constant value. So this rapid attenuation of waves at high frequency, attenuation means their decreasing and damping of oscillations at high frequency circuits established at the surface of a good conductor decays rapidly and we progress into the conductor. So electromagnetic energy is not transmitted in the interior of a conductor. It travels in the region that is surrounding the conductor. It will not travel inside. The extremely short skin depth at microwave frequency indicates that only surface coating of the grinding conductor is significant. Right, now let us see that depth of penetration at radio frequency in good conductor is quite small. This is serving us the purpose of radar waves from metallic surfaces of aeroplanes. Let us see what is skin depth for dielectric or for dielectric or partially conducting media or dielectric, or you can also say insulator. What is the formula for skin depth for this case? Now in this case, sigma is very much less than omega epsilon, right? Or you can say sigma conductivity upon omega epsilon is very much less than 1. So this term 1 upon 1 plus sigma square upon omega square epsilon square, we can approximate it with binomial theorem, sigma square epsilon square to the power of half. So this becomes equal to 1 plus sigma square upon, we have opening the binomial theorem here, 2 omega square epsilon square, like this. Now for good dielectric, skin depth, which is 1 upon attenuation constant, that is omega into mu sigma by 2 into under root 1 plus sigma square upon omega square epsilon square minus 1 to the power of half. Right, now in this term, if we replace it with this term, because we have opened the binomial expression and just taking the first two terms and neglecting the higher order terms, we have neglected. So this term, this we will replace by this term here. So what does the formula for skin depth become? It becomes 1 upon omega into mu epsilon by 2 into 1 plus sigma square upon 2 omega square epsilon square minus 1 to the power of half. This and this gets cancelled and you are left with this much term. So skin depth for dielectric formula becomes skin depth is equal to 1 upon omega into mu epsilon by 2 sigma square upon 2 omega square epsilon square to the power of half. Right, we solve this further. What do we get? We get skin depth expression as 2 upon sigma, that is conductivity, into epsilon upon mu. This is skin depth expression for dielectric, insulator or poor conductor. Notice this expression is independent of frequency. It is independent of frequency. For dielectric, skin depth is independent of frequency. So the penetration depth is independent of frequency in case of dielectric. Thank you.